Now the logistic model has definition number 1. This is the logistic differential equation. P is the population and M is the carrying capacity. So equation number 1 would be dP divided by dt, which is equal to the constant K times the value of the population times the quantity 1 minus the population divided by the carrying capacity. Now in example number 1, what a direction field tells us about solutions of the logistic equation. So we want to be able to draw a direction field for the logistic equation with the constant K, which is equal to 0.08, and carrying capacity M is equal to 1000. What can you deduce about the solutions? So if we take a look at step 1, we know that K is equal to 0.08. We know that the carrying capacity is 1000. If we plug that information into our logistic differential equation, we would get dP over dt, which is equal to 0.08 P times 1 minus P over 1000. Now, if you look over to the right, a direction field for this equation is shown. We show only the first quadrant because negative populations aren't meaningful, and we are interested only in what happens after t equals 0. Now, the logistic equation is autonomous, meaning that dP over dt depends only on P and not on t. So the slopes are the same along any horizontal line. As expected, the slopes are positive for P in between 0 and 1000 and negative for when P is greater than 1000. The slopes are small when P is close to 0 or 1000, the carrying capacity. Notice that the solutions move away from the equilibrium solution where P is equal to 0 and move toward the equilibrium solution P is equal to 1000. So here you can see how the direction of that field is going towards the horizontal line or the equilibrium point at 1000. Now in figure 2, we use the direction field to sketch solution curves with initial populations, P of 0, which is equal to 1000, P of 0, which is equal to 400, and P of 0, which is equal to 1300. So let's go ahead and just take a look at them individually. So the first one, where P of 0 is equal to 1000, it says notice that the solution curves that start below P equals 1000 are increasing. So here at 100, you can see how that direction curve is now approaching that 1000, so it's increasing. Also, if we look at P of 0, which is 400, we can see that that direction is again leading us towards the equilibrium of 1000. And therefore that's increasing. And then those that are starting above, which in this case would be P of 0, which is 1300, is now decreasing going towards that point. Now the slopes are greatest when P is approximately 500, and therefore the solution curves that start below 1000 have inflection points when P is approximately 500. In fact, we can prove that all solution curves that start below P equals equal to 500 have an inflection point when P is exactly 500.